Hello everyone. So this is a continuation of the signal flow graphs video. So in this video, we will see exactly the flow graph diagram representations and each and everything. Okay. So now we are going to discuss about forward paths and loops. This video may go to two parts also. Depend upon time, I will just adjust or I may break the video. Okay. So first we need to understand like the forward paths and loops. Okay. So what are the forward paths and what are the loops? The forward path, which is something like call it as a goes from the input node to the output without repeating any node. Okay, forward path means, for example, if this is A and this is B. Okay, there is nothing is there. Okay, then what we'll call it as a these type of node representations is called forward path, or this type of path is called forward path. There is nothing in between there. Then only it is called as a forward path. Then what is loop means? A loop starts and ends at the same node without repeating others. For example, let's take it as a this is the same. Okay, A and this is B. Okay, but it is saying like it as a it starts and ends with the same node. Let's take it as a this is a self node, right? So then it is called it as a loop. Okay, or some other like something call it as a if A and after that it is coming back to this way, then also it is the same. Okay, but in between B will be there, in between C will be there. In that time also it can come to the same place. It is that one. Where we need to apply is we need to apply the Mason-Gain formula. What is Mason-Gain formula? We will see now. Okay. So Mason-Gain formula. We need to understand to find to apply the Mason-Gain formula to find the transfer function. What we ultimate goal is to find the transfer function by using the Mason-Gain formula. Mason-Gain formula is what is Mason-Gain formula means T equal to summation of the pk and delta k by delta. What is p of pk, delta k and k delta means pk is the gains of the kth forward path. For example, second forward path, third forward path, or eighth forward path. That whatever the gain is there, sorry, that gain is called it as a pk. Okay, and delta k is the delta for path k. That means delta means you already know it is a determination, so that when it determine the output, so that is excluding loop touching, whatever it is that path. Then what is delta is? Delta is 1 minus sum of individual loop gains. For example, individual loop having the gains also will be there. That loops made to minus plus sum of gain products of non-touching loops. Some individual loops we touched, but there are some loops also there, like it as a non-touching loops also may happen. Like for example, some loops may touch, some loops may not touch. Okay, so we need to consider all these things when we are writing a transfer function. So individual loops we need to sum, and also some of the uh, some of gain products of non-touching loops also may happen, and it will go continuously. So this is how the Mason-Gain formula will be written. So we'll see a step-by-step procedure with an example. We will see step-by-step procedure with an example. So let's see to apply with a simple SFG. So it will give a simple block diagram presentation of the loop as it is. We are having a loop called it x1 to x2 to x3. So that x1 to x2 to x3 is a loop. Then what we need to do is, if you see x2 to x2 with a gain of minus h. Okay, the gain is the minus h, and the what are the forward path is the forward path is the g1 g2, and the loop gain for that one is the again the minus h, right? It is already given there. Then what will happen? Delta equal to 1 minus of the sum of individual gains. So individual gains, what is there? We are already having individual gain is minus h, and what are the having non-touching loops are there? There are no non-touching loops there, because if you are touching, there is another non-touching loops or something like that. They are not there, right? So these are not there, so that's why there is no non-touching loops are there. So that's why there is another terminology is not there. So that is completely delta will be equal to 1 plus hash, and delta 1 equal to what is 1 into number of touch and no touching loops 1. So there is only the not touching no touching loops. How many is there? Only one loop is there. So that is that one, that is this g1 and g2. So total loop transfer function is equals to the g1 and g2 into 1 by 1 plus h. Okay, in this way we can able to identify and represent the Mason-Gain formula. Simply this is the transfer function with respective to Mason-Gain formula, not like it as with respect to the any of the mathematical, any of the transfer function, or any of the sorry any of the the differential equations or any other things. It is only represented with respect to the Mason-Gain formulas based technique only. Okay, and we will discuss the another formula, sorry, another example in the next video. So I'm pausing the video here. Thank you.